Hey guys, in this video I want to focus on the inputs. Now we've already had some inputs in the connector, like throttle, engines, mixture, etc. But it didn't have a full-fledged suite, right? Like the buttons aren't in there, the swap, the navigations, the communications. And that's something that is going to change drastically, because right now we have I've changed that all the comms are in, COM1, COM2, all the comms, sorry. The nav1, nav2, you can swap it, you can swap the frequencies around with just a serial command that you send over from your Arduino. So we've all used serial.print line probably when we programmed our Arduinos to debug something, read out a value of a potentiometer, etc. So you should be familiar a bit with serial.print. If you aren't, you can watch one of my other videos where you go more in depth. What the connector does right now, it listens to whatever port you say. So let's say you want to send something over COM22 where your Arduino is connected to, it's going to listen. Okay, I received a 100, so I know 100 is megahertz plus, or 102 megahertz minus. I'm not sure if those are correct. We're going to look at that later in this video. And then it's going to send the command to the game. It's way more smoother than the joystick library, I promise you. You don't have to have those pesky delays in when you press a button, like we've used to, and that would really mess with our rotary encoders, right? So that is something that is improved drastically. It gives us a way to expand more rapidly, because the base is now, the foundation is in, and now we can start building our house. And the variables are something that it's just a bit of code bashing, but it's gonna be in there rather faster than it was before. So if you like this, leave a like, and if you want to get updated, subscribe. And let's just take a look at what has changed and how you can use it. Okay, good morning. Let's just dive right into what I've been doing. We are currently at Frankfurt because I wanted to change the scene up a bit. Somebody is ready to push us back, but we are not gonna yet. Let's see what we have first. Let's just first take a look at the code, shall we? So we can see what it does, and then we can see how it works in reality. So right now, this is the function that handles my rotary encoder. It's a bit more different than the ones I've used in previous videos, so I'm gonna make a new video about this one because I'm also a big fan of this rotary encoder. It has a way better responsiveness in my opinion, and it just feels, the clicks are better, it feels more accurate. So I'm really gonna recommend this one. Is a SparkFun RGB rotary encoder, so you can also, I'm not sure if you can able to tell, but it's quite clearly in shot. It's a red button, but if I click it, it becomes yellow, and you can make it all the colors you'd like. So that's just a nice gimmick, but the rotary encoder itself is also on spot, I believe. It isn't a double rotary encoder like we're used to in lots of the airplanes, like the ones on the G1000, like with the double rings, but it's the same principle if you're used to rotary encoders. It's exactly the same, because these are just two rotary encoders made in one. So the functionality is also the same if you would program that or program this. Let's just go back to the code, shall we? So these lines are the most important to recognize, or to go into. It's a serial.print line, nothing fancy. Everyone has used this to debug something, to see which values are coming in, etc. So we should all be familiar with serial.print line. If you're not, just send a command over serial, and you can read. Normally you can read it. I can't because I have the connector running. Let's see. Stop. You can read it through the serial monitor. So now it's got to reset. Now if I turn, we can see that if I go up or down, a value is passed, right? We'll press a button. Here we go. And here we go. And I've also, on my LCD screen, you can follow along which command is passed. So in my case right now, you can see it's at 116. So we know 116 has been sent last. And if we change it, it goes to 102, 103, etc. Now, what does this do? It does a connector.send kilohertz, standby minus or min. I did a little shortcut there. And it prints it on the LCD screen. And on the other hand, if we go up, we have connector.send kilohertz, standby 1 plus. We also have the same for megahertz. And there's a if statement that if it's in kilohertz mode. Now I've programmed the button, so the rotary encoder has a button. If I click it, you can see the color change. We can see that on the LCD it changed from megahertz to kilohertz. And that tells us if it's in kilohertz mode, it's going to change the kilohertz part of the frequency. If we have it in megahertz mode, you guessed it, it's going to change the megahertz part of the frequency. So before the dot and after the dot. That's all it is really. I went a bit overboard because in the game, if you rotate with your mouse, it has like those steps it takes from, let's say 10, 25, 30, 40, 50, 75. So it has gradual steps. And I believe the 2 and the 7 are always ended with a 5. And that gives us a bit more speed as well. So what happens right now is, I'm going to show you the code. Let's say, let's start with the first. Megahertz standby, right? This is the code of the connector, by the way, which will be open source next month. If we have, if we receive 100, we're going to say first frequency 1 plus is equal 1. So if it's 10, it's going to be 11, 12, 13, 14, 15, 16. So it's going to count up. And it's going to count down if it's 101, because then it's the minus coming in. And it's going to check if it's at a certain range, because I believe the frequency can never be 138. It has to be 136 at the max. If it's higher than that, it goes back to the lowest value, which is 10. So in that way it carries over. It doesn't carry over when you go from the kilohertz to 990. If you tick it, it just goes to 0, which is normal behavior, but the megahertz doesn't go up a tick as well. I'm not quite sure what the original behavior is in an airplane. I'm still looking into if the fractal part carries over the megahertz part. If that's the case, I will change all of this to be more realistic, because right now this was just it's not a test phase. It works, it's fine. I believe this was more user-friendly for myself. If you guys use this a lot and say, Dave, I want it to carry over because that's normal behavior. If you want perhaps another function that you can choose, I can implement that. The functionality is there, so that should be no issue. So what it does, it changes the decimal coming in to a BCD16. It's a binary encoded decimal with 16 bits. It's quite a complex formula. I found it on the internet. I'm going to be honest, I'm not that well versed in these kind of functions. And it's just going to give us something like 0x00123, which stands for 123.000 on your frequency. So it's a bit more complex code. And we're going to see how you guys think it works now, and if it needs some improvements, then just let me know and I'm gonna look into it, how I can improve this for you guys. So let's go back to our code, shall we? Here we go. Now we have connector.send kilohertz standby 1 minus. This is gonna call a function in our library. I'm gonna show you the function in the library as well. Yes, cops. Send megahertz standby 1 plus minus plus. These are all functions you can call. I will put them in the documentation as well, so you can just find the one you need later on without having to like pause my video to see which one you can use. And then it's going to return a value that is down here. It's just an integer like 100, 101. Like I said, it's just a serial command that gets sent over the line. So you could also just replace the entire function by just saying serial.println 101, 100, Only downside is if I ever change anything, like I said before, there's a chance that it changes as well in the library. So, in this case, I have almost no delays. So the rotary encoder should only focus on rotating. And I've programmed the buttons to also swap the navigations, the COM ones and the nav ones. I've also included the nav right now in the connector. So it's a lot of information, just follow along. If you want to use the inputs, you open the connector. There's a big button on top that says switch input output. And it's going to tell you if it's going to send or receive data. Now, if it's going to send data, what in this case is the case, we select the Arduino we'd like to use. We still have to select simple or advanced input for the throttle. It doesn't really affect anything if you don't use it. So you can just select simple or advanced. It's a bit of a little bug I've still in there. Shouldn't affect you that much. It's just to get it started right now. So if I start it, the game is already listening to my Arduino. If the thing, oh, no, it isn't, because I have the serial monitor open. Always close the serial monitor, because else it's going to conflict with each other. Now it's running. And because it isn't receiving data, we don't need the capacitor between the reset and ground like we used to. Now, if we go to comms, we have COM1 megahertz, kilohertz, swap, COM2, nav1, nav2. I still need to do the VOR and DMEs. I was so excited when I saw this one. The G1000 functionalities are already in the SDK documentation, but they don't work in game yet. So it isn't my code that doesn't work. I promise you this time. I've looked on fora. It just doesn't work yet. So I'm gonna implement them because I think it would be really cool if you could create your own G1000 at one point. But right now it just doesn't work. So I already put it up here in caps. So if you miss it, I'm coming after you. I don't want any email saying I've tried to do the G1000 and it doesn't work. Or if they come, I'm gonna send you a nice picture of a cat, something. Let's see, comms. Here is the function that is needed in the Arduino code. So all you need to do is create a connector and then dot send megahertz com send by plus parentheses dot comma. That's all it is. So here I can see serial to print line connector.send kilohertz com send by 1 minus. Now, how did I find that I needed to use this one? I just went to my connector. There's an easy place to find, okay, what did I want to do? I wanted to do the kilohertz minus. So I go, okay, COM1 kilohertz minus is send kilohertz com send by 1 minus. Okay. If you have any questions so far, let me know in the comments. To me, it all sounds logical because I've made it. Perhaps to you, you're a bit more like confused right now because that's the part about creating software, right? I can create something that is in my mind flawless and very accurate and logical, but as a user, perhaps you have a complete different approach than to what I envisioned, and things just don't work out. So let me know if there's anything wrong or could improve, and I'll look into it. Now, finally, the airplane. I've loaded up a Cessna at Frankfurt. Like I said earlier, we're just gonna look. Right now I've got the COM1 set up, right? So we're gonna be focusing on this part. Let me see. Yeah. Right now we're at kilohertz mode. Let's just change that to megahertz mode. And let's rotate upwards. Okay, we can see that the value in the LCD screen changed to 100. So that means COM1 up. We can see that if we rotate upwards, it just carries over to the lower region, the lowest part of the range of the frequency of the megahertz. Here we go, 118. If you go backwards, it goes up. Now, kilohertz, I've clicked it. The color changed to yellow, as you can see. We're at kilohertz. And I'm going to rotate. And I don't know if you remember our old video. I can see if I can get a little clip of it. it just you weren't able to do this. You had to go, especially if you went fast, it went up when you went down, it went down when you went up, and that's because of the delay that we had to implement for the joystick library. Because a bit of a background on the rotary encoder, it's gonna check if the state of, like, there's 2 points. If it hits this one first with a wave, we know it's going leftwards. If it hits this point with a wave, it knows it goes right? But for that, we need to store the last state of the pin and see what the state now is, if it's high, low, etc. Now, if we add a delay, so let's say we hit this point, it keeps rotating, so we add a delay, but the rotation is still in movement, right? The moment the delay stops, it could be that you already ticked 3 times, but because this one is now low while this one was high, for instance, it thinks you took a step back because there's a delay between the reading of the first one and the last one, but the physical position has actually changed. So that was bottlenecking us in using the joystick library for rotary encoders. It worked, perhaps as an axis it worked better, but as a button it just wasn't up to par to my liking, at least. And I hope this fixes that completely, because the delay is completely gone and you can see it's just, I don't know, I've been using my rotary encoders again. At first I thought it was a nice thing to have, nice gimmick to create. It worked, but in reality it was a bit too clunky. And this just takes away all those clunkiness. And I should be able to tell if I go over the 990, if I hit it, it goes to, twice, it goes to 000. So if you guys like that the megahertz carries over as well, let me know and I'll implement that. Let's see, button. I don't know what this one does. Oh, it changes the, see, changes the nav, and this one should change the comms. Yeah, perfect. So that's all working. It was a bit of a struggle to get this to work due to some technical issues. Now that this is implemented, it's just smooth sailing. Wow. Okay. It should be a lot more easier to implement new buttons in the future, because I found that all these buttons are in there in the code. Like I said, the G1000 buttons don't work yet, unfortunately. So when that does, I'm going to keep you updated, because I really want to do this. It would make my life so much easier. Only, I don't know if you guys have the same, the map zoom. Like, I hate, especially if you're in flight and things move. I always screw this up. See, even with mouse, it's not set. If you could just use the rotary encoder, that would save so much hassle. So yeah, I think that covers it right now. If you want to know what functions are available, I have nav1, com1, com2, the swaps for those are all in. That's just the baseline to work from to see if this works. If you guys find any issues, let me know so I can fix them. And I'm going to be working at adding all the buttons you can imagine as an input as well, so you're able to really communicate with your game on a snappy way without being dependent on an Arduino Pro Micro Leonardo or having to spend hours flashing your ROM to work with an input, and it just works out of the box. You could even use something else than an Arduino that uses serial communication, as long as you're able to send commands over a serial line at a baud rate of 11.5200. In the future, I'm able to change it that you have a variable baud rate. Let's say you want to have a device that only can send at 9600. You can just click a checkbox, I want it at a lower baud rate. So that's something I can work out if you guys needed it in the future. So right now you can use it with any device that has a serial communication line at a baud rate of 11.5200. I hope you like this update. It isn't much to show Like I can't show you a full cockpit yet, but it shows the potential it has. It shows also the potential to the snappiness. I thought it would be a little bit slower than the joystick approach, but it's way faster. Just the clicks are almost instant. If you guys have any buttons or clicks you want to see as a priority, let me know, because you know I have to add them anyway. So if you guys want something first, let me know. I already heard some saw a comment about APUs and batteries, etc. So I've already been starting on that. That's coming up in the next update later this week or probably next week. So that is all coming up. If you like it, leave a like down below. And if you want to keep updated, subscribe. And I hope you have lots of safe flights. And if I don't see you before the new year is coming around, have a nice new year.